Welcome back, student. In previous lecture, we are studying about integral transform, in which our new chapter has been started as Laplace transform, in which we have seen the definition piecewise continuity, and after that we have studied about the function of exponential order. We are studying about some basic examples which are be helpful for understanding the definition of function of exponential order. So, we have studied one example in which we have f of x is equal to x raised to n, and we found that x raised to n is a function of exponential order. Before going to start another example, let's see the definition of exponential order. If f of x is any function, then it is called function of exponential order. Function of exponential order if limit x tends to infinity, e raised to minus ax into f of x is any finite number. It is the definition of our function of exponential order. So, taking one more example to understand this, let's see. Prove that the function f of x is equal to e raised to ax. E raised to ax is function of exponential order. Prove that the function f of x is equal to e raised to ax into sine bx, into sine bx is function of exponential order. E raised to ax into sine bx is exponential order. Since we know that the definition limit x tends to infinity, e raised to minus ax, f of x is finite in function of exponential order, left hand side becomes limit x tends to infinity, e raised to ax by definition as it is, and f of x is given as e raised to ax into sine bx. Correct? And if we multiply these e raised to ax into this expression, we will get e raised to minus ax plus a x sine bx. By using law of indices, we will get minus a plus a, we cancel and we get 0. So we will get limit x tends to infinity, e raised to 0x and sine bx. Correct? And if, since we know that a raised to 0 is equal to 1, so limit x tends to infinity, sine bx. Correct? And since we know that the graph of sine function 1 and minus 1. So if we put any limit of infinity, we will get limit of x tends to infinity sine bx is greater or equals to 1, and which is finite quantity. Correct? Which is finite quantity. That's why finite number. Therefore, f of x is equal to e raised to ax sine bx e of x exponential order. Correct? It is function of exponential order. Now, take one more example. Take one more example. Show that the function f of x is equals to. Show that the function f of x show that the function f of x is equal to e raised to x square is not function of exponential order. Since we know that the definition limit x tends to infinity, e raised to minus ax, f of x is equal to finite number, correct? So just taking left hand side, you will get limit x tends to infinity, e raised to minus ax, then x square. By law of indices we can write it as limit x tends to infinity, e raised to x square minus ax, and taking x common we will get x into x minus a, and if we apply limit to this function we will get infinity, and after getting infinity we are not, which is not finite number, therefore f of x is equal to e raised to x square, is not function of exponential, correct? So we have seen three different examples in which first one was x raised to n, which is function of exponential order. After that we have studied about the e raised to ax into sine bx, which is also function of exponential order. And after that, number third, we have learned about e raised to x square, and it is not function of exponential order. So, whenever we want to prove the function is of exponential order or not, we will use this definition to prove that function is of exponential order or not. I think it is enough for today, and we will conclude our function of exponential order. We are going to conclude our topic function of exponential order up to these examples. Now I think you understood what is the piecewise continuity and what is the function of exponential order. We know that the piecewise function is continuous at every subinterval of interval, and the limit point, left hand and right hand limit point of subinterval are different in piecewise continuity function, and in function of exponential order, if a function f of x satisfies this expression, or we will get finite number after taking limit x tends to infinity into e raised to ax of that function. If we get finite number, then we can say that the function is of exponential order, in which we have seen x raised to n is exponential order, e raised to ax, sin bx also exponential of function of exponential order, but the function e raised to x square is not satisfied this equation. That's why it is not function of exponential order. In next lecture we will see some more definitions and theorems which will require for Laplace transform. In that lecture we will see the statement of Laplace transform. Again we will see the proof of that Laplace that theorem and some basic definitions of Laplace transform. So please keep watching our videos. Try to solve each example which we are solving in online class. Try to solve each and every example by yourself to get a clear view about that examples, and keep with us, stay with us, keep watching our videos. Till then, thank you, bye.